Factoring to solve trig equations on an interval. All right. So in the previous video, we did a quick review of factoring and we talked about the zero product rule where we said if you have two things multiplied together and they're equal to zero, then either one or both of these things have to be zero because that's the only way to multiply to zero. We said this was really useful when we had something that was like factored because then you can just set each factor equal to zero and then you're able to solve many equations and find the answers. And that's what we're going to do on on these problems. Um, these are find all solutions in the interval 0 to 2 pi. So when it comes to all solutions, that'll be a later video, but these are on the interval 0 to 2 pi. All right, let's look at this. Sine x times 2 cosine x minus square root 3 equal to 0. So the way that we're going to approach this, we have sine x being multiplied by 2 cosine x minus square root 3. We're going to make this into two equations. I can't stand it when there's little gaps in there. And then if I try to highlight it again, it'll like double highlight it, and I don't like that. Oh, the silly things. Okay. I'm getting used to my pens being laid out different here. Let's try this again. So the first one, we'll let sine x be equal to 0. That is a y value, right? A y value. So we're looking for the places on the unit circle where the y value is 0. It's y value because sine represents y values. So where on the unit circle is the y value 0? Well, let's look over here. That's right there at pi, and it happens over here at 0. Keep in mind when you're doing these problems that you do need to remember it's on 0 to 2 pi, but not including 2 pi. So um, this will be 0, not 2 pi. Even though 2 pi also works, it's not included in the interval of where our answers are allowed to be. My husband just came home. I'm hoping my dog doesn't start barking and ruin my video. Okay. So the solutions to this particular part of the equation is 0 and pi. And then I take the other part. Okay, quit messing up my pens. Let's see. Then I take the other part, 2 cosine x minus square root 3 equals 0. So set that one equal to 0. I rearranged this guy here. So in a previous video, when we talked about solving these types of equations quickly, I'm not going to write out all the algebra anymore because we have talked about it. But you would add the square root 3, you would divide by 2, so you would get cosine of x is equal to square root 3 over 2. Cosine represents x values. So this is saying where on the unit circle is the x value square root 3 over 2? Well, let's see, positive x values. So square root 3 over 2, square root 3 over 2. You're going to notice that a lot of these answers are pi over 6 answers. This was unintentional when I was choosing my examples and I was too lazy to fix it. Although I am quite proud of this worksheet, let me tell you. Anyway, pi over 6 and 11 pi over 6, those ones have x values of square root 3 over 2. So x is equal to pi over 6 and 11 pi over 6. And then all you have to do is combine together these answers. Now, I'm going to put them in the order that they appear in the unit circle. But you can list these in any order. You could go 0, pi, pi over 6, 11 pi over 6. It doesn't have to be in the order on the unit circle. So let's see, x is equal to 0 works, pi over 6 works, pi works, 11 pi over 6 works. And you could try it. You can plug each of these values in for x up here in this equation, and they will all work. And that's all these ones are. It really is that simple. We'll do another. We have one equation. We have two factors really. We're going to set each of these factors equal to 0. So we have cotangent x plus 1 equals 0. Cotangent x is equal to -1, right? We know that cotangent, got to get used to how I've done my little pen. Cotangent is x divided by y. We talked about this in the very first video, how as it relates to cotangent, you can just divide the numerators. You can just pretend that the twos don't exist because when you divide, they're going to cancel anyway. So I'm looking for when I divide, oops, there's my dog. So I am looking for the two values in the numerator when I divide them and they become -1. I can also look at, I can look at all students take calculus. I know that cotangent is negative, which means tangent has to be negative. So the quadrants where tangent is negative are going to be quadrants 2 and 4. So I know my solutions are going to be in quadrants 2 and 4. And clearly it's going to be these square root twos, right? So if I do negative square root 2 divided by square root 2, that comes out to be -1. So it's this 3 pi over 4 angle. And then it's going to be the pi over 4 angle down in quadrant 4. Because if you divide the x value, square root 2, divided by negative square root 2, that will also come out to be 1. So for the first equation, we get 3 pi over 4 and 7 pi over 4. And then for the next equation, we have cosecant of x is equal, or plus square root 2 is equal to 0. Cosecant of x is equal to negative square root of 2. We look at the soulmate, the partner, the forever partner of cosecant, which is sine. And that means sine of x is equal to -1 divided by square root 2. Now, looking at my unit circle, clearly there aren't any y values that are 1 over square root 2. We do need to rationalize this by multiplying the numerator and denominator by square root 2. And we get negative square root 2 over 2. So we're looking for when is the y value negative square root 2 over 2? So I come here, negative y values will be on the bottom part of the circle. Y equal to negative square root 2 over 2. Oh, that happens here at 5 pi over 4. And it happens here at 7 pi over 4. So 7 pi over 4 ends up working for both equations. We get x equal to 5 pi over 4 and 7 pi over 4. When we go to write our final answer, we only need to include 7 pi over 4 one time. So we have a total of 3 solutions. One of them ends up working for both. So we have x is equal to 3 pi over 4, 5 pi over 4, and 7 pi over 4. Boom. There they are. All right. Looking at this guy here, we have 2 sine x minus square root 3 times tangent of x minus 1. Set each of those equal to 0. 2 sine x minus square root 3 equal to 0. That means that sine x is equal to square root 3 over 2. That is a y value. So where is the y value, square root 3 over 2? Positive, so these two quadrants. Square root 3 over 2, oops, that's an x value. Square root 3 over 2 as a y value. Square root 3 over 2 as a y value. That's at 2 pi over 3 and pi over 3. And then for my next equation, tangent of x minus 1 is equal to 0. Tangent x is equal to 1. All students take calculus. Tangent is positive. We are looking at quadrants 1 and 3 will be where our answers are. And that when tangent is 1, that's going to happen at those pi over 4 angles, right? Square root 2 divided by square root 2 is just 1 when you divide these guys. So it's the pi over 4 angle in quadrant 1 and the pi over 4 angle in quadrant 3. Negative square root 2 over 2 divided by negative square root 2 over 2 is 1. So I have x equal to pi over 4 and 5 pi over 4. I have 4 total answers here. Again, I'm going to put them in the order they come on the unit circle, but you put them in any order and it's correct. I have pi over 4, pi over 3, 2 pi over 3, and 5 pi over 4. Cool. All right. Now, sometimes these aren't factored to begin with. And I'm I'm going to talk you through the factoring process here. So 2 sine squared x plus 3 sine x plus 1 is equal to 0. Find the answers on the interval 0 to 2 pi. This is what I like to call an undercover quadratic. Undercover quadratic, because it's a quadratic. It just doesn't know that it's a quadratic yet. I see a squared term, a singular term, and a constant. And that reminds me quite a bit of ax squared plus bx plus c, a quadratic. We do a really simple substitution here. You can use any variable you want. I'm going to choose u because in calculus you do something called u substitution. So I like the use of u for substituting. And I'm going to take this sine squared x and sine x. I'm going to make u equal to sine x. I can rewrite this now as 2 u squared instead of sine squared, u squared plus 3u plus 1 equal to 0. So I have replaced those signs with u's. This is something I can factor. There's a previous video I do on how to factor these. So I'm just going to tell you what the factorization becomes. U plus 1 times 2u plus 1 is what this would factor into, regardless of the method you use to factor it. Now I can, take these u's and replace them with sine. Go back to the sign. So put sine in wherever you see a u. So we have sine x plus 1. We have 2 sine x plus 1 equal to 0. Again, what happened? I took the u and I replaced it with sine x. You can also go straight from here to here if your brain is cool with that, if you're able to kind of see that how this factors better. But it can help to do this intermittent step here where you make it into a quadratic you're familiar with, then factor, then substitute back. All right. So I'll take this first factor because now we have 2 factors multiplied set equal to 0. Use the 0 product rule. We get sine x plus 1 equal to 0. That means sine x is equal to -1. Where is the y value? Where is the y value? Because it's sine. Where's the y value? Equal to -1. Come on over to our unit circle. Well, y value is -1 in only one place. It's at 3 pi over 2. So for this equation, we have 3 pi over 2. For the second equation, 2 sine x plus 1 equals 0. We get sine x equal to -1/2 after moving things around. So where is the y value? -1/2. Come over here. Negative y values are on this bottom half of the circle. Where is the y value -1/2? I told you there's a lot of pi over 6 answers here. 7 pi over 6 and 11 pi over 6. 7 pi over 6, 11 pi over 6. And then I'm just combining together all my answers. So I have x is equal to 7 pi over 6, 3 pi over 2, and 11 pi over 6. Boom, not so bad. I think these look a lot scarier than they actually are. It just takes a bit of knowledge about factoring and then it all comes out. And it's all the things you've done before. One last example for this video. We have secant squared theta plus secant theta minus 2 equals to 0. I am going to do a substitution here. So for my substitution, I'm going to let u be secant theta because I see a squared secant, a regular secant, and a constant. This becomes, instead of secant squared, u squared plus, instead of secant, it's u minus 2 equal to 0. This factors into u plus 2 times u minus 1. I'm going to substitute secant back in for u. So for each of these u's, I'm going to put secant in. I have secant theta plus 2 times secant theta minus 1 equal to 0. Those are boom, boom. Now we have two factors multiplied together that equal to 0, so I can use that zero product rule. Secant theta plus 2 equal to 0 means that secant theta is equal to negative 2. I think about the soulmate partner, in forever best friend of secant, which is, let me draw the heart. The heart is really important. Um, Cosine. Cosine of theta is the flipsy flu, is the reciprocal of negative 2, so it'll be negative 1/2. Cosine represents x values, right? So we're asking ourselves, where is the x value negative 1/2 on the unit circle? I know that negative x values happen on the left half of the circle. Where is the x value equal to negative 1/2? Oh, well, that's up here at 2 pi over 3. And additionally, down here at 4 pi over 3. The x values are negative 1/2. So we get theta equal to 2 pi over 3 and 4 pi over 3 for that first equation. For the next equation, secant theta minus 1, we get secant theta minus 1 equal to 0. Secant of theta equal to 1. Again, soulmates, right? Soulmates, very important. Do the little heart, make sure that's in your notes. With cosine. The reciprocal of 1 is just 1. We're looking at the x value. So where on the unit circle is the x value 1? Well, the x value is 1 only at one place over here at 0. So we get theta equal to 0. If we combine together all of our answers, we have theta equal to 0, 2 pi over 3, and 4 pi over 3. And those are our answers. All right, so that's it. It's really not that much more than what you're doing. You're just um, you're factoring it, using the zero product rule, and solving a basic trigonometric equation. All right, that's all I have for you here. I will see you in the next video. Bye.